Hello one and all, welcome to another online video by Einstein Academy. In this video, we'll be looking at learning outcomes D and E from the topic of atomic structure from the JCH2 chemistry syllabus. Learning outcome D says that candidates should be able to deduce the numbers of protons, neutrons, and electrons present in both atoms and ions given the proton and nucleon number as well as the charge. Learning outcome E, on the other hand, says that candidates should be able to describe the contribution of protons and neutrons to atomic nuclei in terms of proton number and nucleon number, basically the definition for proton number and nucleon number. And E part 2 is to be able to distinguish between isotopes on the basis of different numbers of neutrons present. We will be able to define isotopes at the end of this video. So, as we've mentioned previously, every atom is made up of three subatomic particles, the proton, the neutron, and the electron. Now, from atom to atom, the only difference is in the number of protons, the number of neutrons, and number of electrons that each atom consists of. So we would like a way to basically denote the number of protons, the number of neutrons, and the number of electrons that every single species have. And this is the way that we will denote the corresponding numbers. The proton number is defined to be the number of protons in the nucleus of an atom, and it is commonly represented by the symbol Z. On the other hand, the nucleon number is the number of protons and neutrons in the nucleus of an atom. So basically, the nucleon number is the sum of the number of protons plus the number of neutrons, and is commonly represented by the symbol A. Putting it all together, we can see this symbol whereby X is the chemical symbol for the element, A is the mass number, and Z is the atomic number. Now, given the mass number, which is the number of protons plus the number of neutrons in the nucleus and the number of protons, we can simply take the nucleon number, which is A minus Z, to arrive at the number of neutrons in a given atom or a given ion. If we were to look at the periodic table, we can see basically the proton number and the nucleon number of different elements. I would just like to point out that in this particular periodic table, the nucleon number is the number that is at the bottom, while the proton number is the number at the top. It is not by convention that the nucleon number must always be at the bottom, while the proton number must always be at the top. It can actually be the reverse in the sense that the nucleon number is at the top and the proton number is at the bottom. But clearly, if the nucleon number is the sum of the number of protons and the number of neutrons, it must be the bigger number. In other words, when you look at any periodic table, just understand that the bigger number is always the nucleon number, while the smaller number is always just the proton number. So now we'd like to discuss the charge on an atom. Atoms are electrically neutral, where the number of protons is equal to the number of electrons. So if that species is uncharged, whereby it's an atom, then it must be true that the number of protons is equal to the number of electrons. On the other hand, this is not true of ions, because the definition for ions is that they are electrically charged species. And for atoms, the only way that can gain charge or lose charge is to gain or lose electrons. Atoms are never able to undergo processes whereby they gain or lose protons, because that would be a nuclear process, which is not really a reaction that most chemical reactions take part in. So again, to emphasize, atoms can only gain or lose electrons, and when they gain or lose electrons, they will form either negatively charged species or positively charged species, which are called ions. As an example, when a sodium atom loses one electron, it will form the Na plus ion because it now has one more proton than electron, or the number of electrons is one less than the number of protons. On the other hand, if aluminium loses 3 electrons, it will form the Al3 plus ion because the number of electrons is now 3 less than the number of protons. From the nucleon number and the atomic number, one can thus calculate the number of neutrons in a given atom or an ion. So for example, given this symbol, whereby it has 12 protons plus neutrons and 6 protons, it would mean that the atomic number is given, which is 6, so it has 6 number of protons, and the number of neutrons will simply be the nucleon number minus the proton number, which is equals to 6. And since this species doesn't have a charge which is either plus or minus attached to it, it's electrically neutral, meaning that the number of electrons must be exactly equal to the number of protons, which is also equal to 6. Looking at another example, this symbol for the Na1 plus charged ion, the number of protons is 11, given by the proton number, while the number of neutrons is again the number of nucleon minus the number of protons, which is 23 minus 11 to be given to be 12. And since in this case, the Na plus ion has one less electron as compared to the number of protons, and we know that the number of protons is 11, the number of electrons will be given to be 11 minus 1, which is exactly equals to 10. A few more examples, Al3 plus, the number of protons is 13, while the number of neutrons is 27 minus 13, which is 14. And since it has a charge of 3 plus, it will have 3 more protons than that of electrons, and hence the number of electrons is simply 13 minus 3, which is equals to 10. On to some examples for negatively charged ions. For the F minus ion, the number of protons is 9. The number of neutrons is 19 minus 9, which is equal to 10. And since it has a charge of 1 minus, it means that it has 1 more electron than the number of protons, and hence the number of electrons is simply 9 plus 1, which is equal to 10. The final example for the O2 minus N ion, it has a number of protons which is equals to 8. The number of neutrons will be equals to 16 minus 8, which is equals to 8 as well. And since it has a charge of 2 minus, it will have exactly 2 more electrons than the number of protons, which is given to be 8 plus 2, which is equals to 10. The final slide here, we would like to define the definition of isotopes in the sense that isotopes are defined to be atoms of the same element which have the same number of protons but different number of neutrons. If you change the proton number, it will actually change from one element to another element. So if we go back to the periodic table, right, you can see that the boron has 5 protons and the carbon has 6 protons. So if the number of protons changes, it will not be the same element anymore. So what you are only able to change in a given atom, if it's of the same element, is in the number of neutrons. And that is exactly what the definition of isotopes are. They have the same number of protons, therefore it's the same element, but different number of neutrons. And since in all chemical reactions, the chemical reactions only involves reactions which involve the valence electrons, and since the chemical properties of that is only determined by the number of valence electrons, since isotopes have the same number of valence electrons, they will also have the exact same chemical properties because they only differ only by the number of neutrons. However, the number of neutrons will mean that the masses of the different isotopes are different, and different masses will result in slightly different physical properties. So due to the different masses, they will have slightly different physical properties. So isotopes have the same chemical properties because they have the same number of valence electrons, but they have slightly different physical properties due to the difference in masses, due to the difference in the number of neutrons. Okay, so having gone through all those slides, candidates hopefully now should be able to deduce the number of protons, neutrons, and electrons present in both atoms and ions given proton and nucleon numbers. So these are basically these 4 examples that we have gone through: Na+, Al3+, F-, as well as the O2- ion. Describe the contribution of protons and neutrons to atomic nuclei in terms of proton number and nucleon number. You have to know the definitions for proton number, which is basically the number of protons, whereas the definition for the nucleon number is the number of protons plus the number of neutrons in the atomic nuclei of any atom or ion for the matter. Distinguish between isotopes on the basis of different numbers of neutrons present. Basically be able to state the definition of isotopes. They are elements with the same number of protons but different number of neutrons. Okay, so this video, we sum up learning outcome D and E from the topic of atomic structure from the JCH2 chemistry syllabus. If you like this video, just hit the like and subscribe button, and we'll come back for another episode where we tackle the next few learning outcomes from the topic of atomic structure from the JCH2 chemistry. Thank you for your time and see you again.